Almost all vehicle accidents are caused by human error, which can be avoided with advanced driver assistance systems, also known as ADAS. The role of ADAS is to prevent deaths and injuries by reducing the number of car accidents and the serious impact of those that cannot be avoided. The ADAS systems are passive and active safety systems designed to remove the human error when operating vehicles of many types. The ADAS systems use advanced technologies to assist the driver during driving and thereby improve drivers' performance. It uses sensors in the vehicle such as radar and cameras to perceive the world around it, and then either provides information to the driver or takes automatic action based on what it perceives. The modernization of ADAS applications is the first steps toward realizing autonomous vehicles. Now let's understand how does the ADAS system works. Self-driving cars use a variety of technologies to gain 360-degree vision, both near and far. The ADAS system consists of sensors, various chips called systems on a chip, interface, and a powerful computer processor that integrates all of the data and makes decisions in real time. The implementation of cameras in the vehicle involves a new AI function that uses sensor fusion to identify and process objects. Sensor fusion is similar to how the human brain processes information. It combines large amounts of data with the help of image recognition software, ultrasound sensors, LiDAR, and radar. This technology can physically respond faster than a human driver ever could. What ADAS do that human can't? The ADAS-equipped vehicles have an array of advanced sensors that augment the eyes, ears, and decision-making of the human driver. Can you see in the dark? Not very well, but radar can. Can you echolocate like a bat or a dolphin to determine if there's a child behind your car before you put your car in reverse? No, but sonar sensors can. Can you see in all directions at once? No, but cameras and LiDAR sensors can. Do you know your exact latitude and longitude at all times? No, but several constellations of global positioning satellites in space can send that information to your car. ADAS levels. Advanced Driver Assistance System levels are technical features that are intended to improve vehicle safety. They are categorized into different levels based on the amount of automation and the scale provided by the Society of Automotive Engineers. The ADAS system can be divided into 6 levels. Level 0. In Level 0, the driver is entirely responsible for managing the vehicle, including steering, braking, accelerating, and slowing down. In Level 1, the vehicle has at least one driver support system that provides assistance in, for example, adaptive cruise control, which maintains a safe following distance behind traffic ahead without intervention from the driver. In Level 2, the vehicle can perform steering and acceleration. The driver still monitors all tasks and can take control at any time. A Level 3 ready autonomous vehicle is capable of driving itself in particular conditions, during which it will take control of all safety-critical systems. Nonetheless, when the system asks it, the driver is supposed to take control. In Level 4, you can take a nap while riding in the vehicle. Level 4 driving automation technology is for use in driverless taxis and public transportation services. Such vehicles will be programmed to travel between point A and point B and restricted to specific geographic boundaries by geofencing technology. And in Level 5, the vehicle performs all driving tasks under all conditions. In this level, zero human attention or interaction is required. Now let's discuss every ADAS system one by one, starting with Adaptive Cruise Control. Adaptive Cruise Control is designed to help road vehicles maintain a safe following distance and stay within the speed limit. This system automatically adjusts a car's speed, so drivers don't have to. Advanced Cruise Control can automatically accelerate, slow down, and sometimes stop the vehicle, depending on the action's other objects in the immediate area. It is constructive on the highway, where drivers can find it challenging to monitor their speed and other cars over a long period. Crosswind Stabilization. Crosswind assist detects track offset caused by strong crosswinds on time and thus helps the driver to remain in their lane. A sudden track offset of the vehicle can cause improper steering reactions of the driver. That's why Crosswind assist automatically corrects the vehicle's course from a speed of 50 miles per hour. This system distributes the wheel load to the velocity and direction of the crosswind. And it was first featured in a 2009 Mercedes-Benz S-Class. Traction control system. A traction control system helps prevent traction loss in vehicles and prevent vehicle turnover on sharp curves and turns. The TCS system detects if a loss of traction occurs among the car's wheels and automatically applies the brakes to that individual or cuts down the car's engine power to the slipping wheel. These systems use the same wheel speed sensors as the anti-lock braking systems. Individual wheel braking systems are deployed through TCS to control when one tire spins faster than the others. Electronic stability control. It helps prevent loss of control in curves and emergency steering maneuvers by stabilizing your car when it begins to veer off your intended path. The electronic stability control system can lessen the car's speed and activate individual brakes to prevent understeer and oversteer. In simple words, it works automatically to help the driver maintain control of the car during hard steering maneuvers. Parking sensors. Parking sensors are proximity sensors for road vehicles designed to alert drivers of obstacles while parking. These systems use either electromagnetic or ultrasonic sensors. Parking sensors can scan the vehicle's surroundings for objects when the driver initiates parking. Audio warnings can notify the driver of the distance between the vehicle and its surrounding objects. Typically, the faster the audio warnings are issued, the closer the vehicle gets to the object. Automatic parking assist. Automatic parking controls parking functions, including steering, braking, and acceleration, to assist drivers in parking. This technology uses sensors, radars, and cameras to take autonomous control of parking tasks, helping drivers safely and securely store their vehicles without damaging them or other cars parked nearby. These vehicles have rear-view cameras, making parking faster and safer even when parallel or reverse parking is warranted. The driver must still be aware of the vehicle surroundings and be willing to take control if necessary. Driver Emergency Stop Assist. Driver Emergency Stop Assist facilitates emergency counteract measures if the driver falls asleep or does not perform any driving actions like pressing the accelerator, brake, or moving steering wheel after a long period of time. Then the car will send audio, visual, and physical signals to the driver. If the driver does not wake up after these signals, the system will stop, safely position the vehicle away from oncoming traffic, and turn on the hazard warning lights. Hill Descent Control. Hill Descent Control is a driver assistance system that helps maintain a safe speed when driving down a hill and allows a controlled hill descent in rough terrain without any brake input from the driver. These systems are typically enacted if the vehicle moves faster than 15 to 20 miles per hour when driving down. This system works by pulsing the braking system and controlling each wheel independently to maintain traction down the descent. Lane Centering Assist. Lane centering assistance is currently the highest level of lane monitoring technology, and this system proactively keeps the vehicle centered within the lane it is traveling. It utilizes automatic steering functionality to make constant adjustments based on road marking information from the front-mounted camera. Lane Departure Warning System. The Lane Departure Warning System is designed to warn the driver when the vehicle begins to move out of its lane on freeways and arterial roads. An LDW system uses cameras to monitor lane markings to determine if the driver unintentionally begins to drift. This system does not take control of the vehicle to help sway the car back into the safety zone, but instead sends an audio or visual alert to the driver. Lane Change Assistance. This assistant informs the driver of potential hazards when changing lanes on roads and highways with several lanes. When a driver intends to make a lane change, the vehicle will notify the driver through an audio or visual alert when a car is approaching from behind or is in the vehicle's blind spot. The visual alert may appear in the dashboard, heads-up display, or exterior rearview mirrors. Rain sensors. Rain sensors detect water and automatically trigger electrical actions such as the raising of open windows and the closing of open convertible tops. A rain sensor can also take in the frequency of rain droplets to automatically trigger windshield wipers with an accurate speed for the corresponding rainfall. Collision avoidance system. A collision avoidance system, a pre-crash system, a forward collision warning system, or a collision mitigation system is designed to help prevent avoidable crashes. This system uses various technologies and sensors such as radar, lasers, cameras, GPS, and artificial intelligence. Not all collision avoidance systems are created equally. Some warn or alert, while others override the driver to assist them in avoiding collisions and mitigating risk. Automotive head-up display. It safely displays essential system information to a driver at a vantage point that does not require the driver to look down or away from the road. Currently, the majority of the head-up display on the market displays system information on a windshield using LCDs. Automotive navigation system. Navigation systems use the Global Navigation Satellite System Network to pinpoint the location of your car anywhere on the globe. The system in your car communicates with these satellites and displays the vehicle's location on a local map. Car navigation systems provide on-screen instructions and voice prompts to help drivers follow a route while concentrating on the road. Some navigation systems can display exact traffic data and, if necessary, plan a new route to avoid traffic jams. Traffic sign recognition. Traffic sign recognition is a technology by which a vehicle can recognize the traffic signs on the road, such as speed limit, turn ahead, or stop. This system considers the sign's shape, such as hexagons and rectangles, and the color to classify what the sign is communicating to the driver. Since most systems currently use camera-based technology, many factors can make the system less accurate. These include poor lighting conditions, extreme weather conditions, and partial obstruction of the sign. Vehicle communication systems. These systems are computer networks in which vehicles and roadside units are the communicating nodes, providing each other with information such as safety warnings and traffic information. Vehicle communication systems come in three forms: vehicle-to-vehicle, vehicle-to-infrastructure, and vehicle-to-everything. Vehicle-to-vehicle communication enables vehicles to wirelessly exchange information about their speed, location, and heading. Vehicle-to-infrastructure communication is the wireless data exchange between vehicles and road infrastructure. V2X stands for vehicle-to-everything and refers to parsing information from a vehicle to any entity that may affect the vehicle and vice versa. Automotive night vision. Night vision systems enable drivers to see things that would otherwise be difficult or impossible at night. This system will allow the vehicle to detect obstacles and pedestrians in a nighttime or heavy weather situation when the driver has low visibility. It uses various technologies, including infrared sensors, GPS, LiDAR, and radar. There are two categories of night vision implementations: active night vision systems, project infrared light, and passive systems rely on the thermal energy that comes from cars, animals, and other objects. Such systems are offered as optional equipment on certain premium vehicles. Rear view camera. The rear view camera provides real-time video information regarding the location of your vehicle and its surroundings. The camera is located in the rear of your car and is connected to a display screen that shows you what is happening in the area behind the vehicle. This camera offers driver's aid when backing up by providing a viewpoint that is typically a blind spot in traditional cars. The camera automatically turns on when the driver puts the car in reverse. OmniView technology. The OmniView technology improves a driver's visibility by offering a 360-degree viewing system. This system can accurately provide 3D peripheral images of the car's surroundings through a video display outputted to the driver. In a common OmniView system, there are 4 wide-field cameras. one in the front of the vehicle, one in the back of the vehicle, one in the left rearview mirror, and one in the right outside mirror. The 4 cameras cover the whole area around the vehicle. OmniView technology uses the input of 4 cameras and a bird's eye technology to provide a composite 3D model of the surroundings. Blind spot monitor. Blind spots are the areas behind or at the side of the vehicle that the driver cannot see from the driver's seat. Blind spot monitor involves cameras that monitor the driver's blind spots and notify the driver if any obstacles come close to the vehicle. It uses a sensor device that detects other vehicles to the driver's side and rear, and the warnings can be visual, audible, or vibrating. Driver drowsiness detection. Driver drowsiness detection aims to prevent collisions due to driver fatigue. The vehicle obtains information such as facial patterns, steering movement, driving habits, turn signal use, and driving velocity to determine if the driver's activities correspond with drowsy driving. If drowsy driving is suspected, the vehicle will typically sound awful out alert and may vibrate the driver's seat. Various studies have suggested that around 20% of all road accidents are fatigue-related. Intelligent speed adaptation. Intelligent speed adaptation involves advanced systems that assist drivers in sticking to the speed limit. This technology takes in the information of the vehicle's position using a global navigation satellite system such as GPS is linked to a speed zone database that allows the vehicle to know its location and the speed limit on that road. Some ISA systems allow the vehicle to adjust its speed to the relative speed limit. Other systems only warn the driver when they are going over the speed limit and leave it up to the driver to enforce the limit or not. Adaptive light control system. Unlike traditional headlights, which are in a fixed position and only capable of illuminating directly in front of you, but adaptive headlights are not in a fixed place at all times. These headlights use electronic sensors that can detect your steering angle to swivel based on your car's direction and also helps other drivers from being impacted by a vehicle's headlights. This technology automatically dims headlights to a lower beam when oncoming traffic approach us and then brightens them once the traffic has passed. Automatic emergency braking. If an imminent forward collision is detected, automatic emergency braking systems automatically apply brakes without waiting for the driver to react. The system uses sensors to see whether the driver is in the process of hitting another vehicle or other objects on the road. This application can measure the distance of nearby traffic and alert the driver to any danger. Some emergency braking systems can take preventive safety measures, such as tightening seat belts, reducing speed, and engaging adaptive steering to avoid a collision. So, what do you think about the ADAS systems? Which features do you want to see in upcoming cars? Let me know in the comments. Do you really know what your car's dashboard warning light's trying to tell you? If yes, then you should check out this video.